morning, students. Today we are going to start with next topic. In the previous part we have studied binary addition and binary subtraction. That is how we have to perform addition of two numbers, that is 0 and 1, and how we have to subtract two binary numbers, where we have studied these tables. See, this is the addition. So when we add two ones, we always get the result as 0 with one carry, and this is subtraction. When we subtract the numbers, we get the results as follows. So in the previous lecture, we have studied binary addition and subtraction. Today we are going to start with next topic, that is ones complement. Ones complement of a number. So this is very easy method. You just have to apply the mechanism. So what we have to do whenever we have to convert any number into ones complement number, we just have to replace the 0 with the 1 and 1 with the 0. It means if the given number is 0, you have to convert it into 1. If the given number is 1, you have to convert it to 0. That is ones complement. You know, students, that complement means inverse of a number. So ones complement is when we change it once to another bit. So I have taken an example of ones complement method. For example, the number is 0, 1, 0, 1, 1, and we want to obtain ones complement of this number. So the ones complement of this number is, see, the first bit is 0. So the ones complement of this bit is 1, 1, 0. Ones complement of 0 is 1, 0, 0. So this number is the ones complement number of this number. Now the question is why we are using this ones complement method. See, students, you know that computer understands only binary number, and computer deals with the binary numbers to perform addition, subtraction, multiplication, division. So when we have to subtract large numbers, or when we have a data with large numbers, how we can subtract, or how computer subtract these numbers? Computer always apply these mechanisms, these methods to subtract the numbers. So that's why we have to study these mechanisms, ones complement. So this is ones complement, and it is very easy and simple method. So after ones complement, the next method is twos complement. Twos complement is bit different from ones complement. So as it is twos complement, it is extension of ones complement. So what we have to do whenever we have to obtain twos complement of any number, so first of all we have to convert that number into ones complement, and after that we have to add 1 to the least significant bit position, to the LSB. So I will show you that how you have to convert twos complement of any binary number. So for example, the given number is 1, 0, 0, 1. So what we have to do is, first of all, we have to convert ones complement of this number. So this is the ones complement of this number. The ones complement of 1, 0, 0, 1 is 0, 1, 1, 0. So till this point we have just obtained ones complement of this number. Now we have to add 1 to ones complement to obtain twos complement. Now add 1 to the least significant bit. This is the least significant bit. Add 1. So this is the one. Now you have to obtain the result by performing binary addition. So 0 plus 1 is 1. Now next number is 1. This is 1. Next number is 1. This is 1. And the last number is 0. So this is 0. So the most significant bit is 0. So this is how we can obtain twos complement of any number. So see, students, this is very easy method. This is a very basic method, that is ones complement and twos complement. So again I want to tell you that what you have to do in ones complement, you just have to inverse the bits. you just have to convert the bits, that is 0 to 1 and 1 to 0. So this is 1's complement method. Now the next method is 2's complement. In 2's complement, if you want to obtain 2's complement of any number, you just have to first of all convert that number into 1's complement, then add 1 to that 1's complement number, and at the end you will get 2's complement of that number. So I have taken one more example of 2's complement. For example, the given number is 10010. So what we have to do is, we first of all we have to convert this number into 1's complement. So this is 1's complement of this given number. So the 1's complement of this number is 01101. Now add 1 to this number, so you will get the final number as 01110. So this is 2's complement of this 10010 number. So by this we can simply get 1's complement and 2's complement. Now let's move to next topic of this unit. The next topic is subtraction using 1's complement. See students, earlier in the previous video I have told you that how you have to subtract two binary numbers and how you have to perform subtraction on binary numbers. Now this is a method of subtraction, but this is not normal subtraction. This is just a mechanism. By applying these rules we can calculate subtraction of any numbers without subtracting the numbers. Okay, so that's why the name of this method is subtraction using 1's complement. So what we have to do in this method is, we have to subtract two numbers by using 1's complement method. So there are some procedures, there are some steps in this method, and you always have to follow these steps whenever you have to perform subtraction of two numbers. So it is up to you and it is up to the computer, whatever method you want to use, or whatever method computer is using. Different methods are available, you can use according to your choice. Okay, so let's start with this method, subtraction using 1's complement. So first of all, what is this method? So 1's complement subtraction is a method to subtract two binary numbers. This method allows subtraction of two binary numbers by addition. So this is very important point, that this method allows subtraction of two binary numbers by addition. So as I have already told you that in this method we do not have to perform subtraction, even we have to perform addition to get the result, as in a subtraction of two numbers, but without performing subtraction method we have to obtain the result by performing addition. So now we will see how we have to perform all the steps. So look at this point, subtraction of smaller number from the larger number. So whenever we have to subtract any small number from the larger number, so what we have to do, for example, the given number is 9 and we have to subtract 7 from 9, that is 9 minus 7. So how we can perform this type of subtraction on binary numbers? By using 1's complement method. So the steps for 1's complement subtraction of a smaller number from a larger number is as follow. Look at step number 1. So in the first step, what you have to do is, you have to calculate the 1's complement of a smaller number. See students, in this we have two numbers, one is the larger number and one is the smaller number. So whatever is the smaller number, for example I have given you the example of 9 minus 7. So what we have to do is, we have to calculate the 1's complement of the smaller number. It means we have to calculate the 1's complement of 7 in case of in terms of binary number. Step number 2 is add this to the larger number. So after calculating the 1's complement of the smaller number, you have to add this number to the larger number. So this is step number 2. Now step number 3 is, if there is a carry, there are chances that if it can generate carry at the most significant bit. So if there is a carry, remove the carry and add it to the result. So what we have to do is, if we get a carry, we have to remove the carry and we have to add that carry to the low significant bit. Now I will show you with example because it will be more clearer to you with the example. So first of all, let's move to example. So this is a very simple example that I have taken. So let's start from the very first step. So for example, we have to subtract 1010 from 1111. So students, I hope that you know that what is the decimal equivalent of this number. So I have not here given the decimal equivalents. I have just taken the examples of binary numbers because we have to deal with binary numbers. So this is basically 10 and this is 15. 10 minus 15 minus 10 and we will get the answer as 5. Okay. So let's start with this method. So we have to subtract 1010 from 1111. Okay, so this is the smallest number. So what we have to do is, first of all, we have to calculate ones complement of this method. Okay, so let's start by calculating the ones complement of this number. So I have written here, look at step number 1, find the ones complement of 1010. So after reversing all the numbers, we will get the answer as 0101 because ones complement of 1010 is 0101. Okay, step number 1 is done. Now move to step number 2. In step number 2, we have to add this complemented number to the larger number to get the result. So look at this step. So this is the given number which is given in the question 1111. Okay, so these are 4 bits. Now we have to subtract this number 1010. We have already generated, we have already calculated ones complement and the result was 0101. Okay, so this is the first step where we have calculated the ones complement. Now we have to add these two numbers. So let's start adding these two numbers from the rightmost position, that is from the least significant bit. So 1 plus 1 is 0 with 1 carry. So the answer is 0 with 1 carry. Now here we have carry 1. 1 plus 1 is again 0 with 1 carry. Now here we have triple ones, 1 carry and 2 ones are already given. So triple 1 is always 1 with 1 carry. If we add 3 ones, we always get the result as 1 with 1 carry. Why 1 with 1 carry? If we add 2 ones, we always get result as 1 plus 1 is 0 with 1 carry. So if 1 plus 1 is 0 with 1 carry, then 1 after calculating the 2 ones, we get the answer as 0. And if there is a 0, 0 plus 1 is again 1 and we have already generated carry. So triple 1 is always 1 with 1 carry. So here we also have 2 ones, 1 plus 1 is 0 with 1 carry. So this is the final result that we have generated after adding these two numbers. Now I have told you that if we get carry, we have to remove that carry and we have to add that carry to the low significant bit, to the least significant bit. So remove the carry from this position, add this to the least significant bit. So add 1, 0 plus, now add these two numbers. 0 plus 1 is 1, 0, 1, 0. So this is the final answer. So see students, how we have subtracted two numbers without actually performing subtraction mechanism. See, you can see in this example, I have not subtract any number from any number. What we have to do is we have to add the numbers by first of all applying the ones complement method. So now look at this slide that where I have told you that you do not actually have to subtract two numbers, you just have to apply addition mechanism by applying ones complement. So that's why student we have studied ones complement and twos complement method. And I have already told you that computer can make use of any of the mechanism to perform subtraction of two numbers. And even this is very easy way to subtract any two numbers. because otherwise sometimes it creates chaos on the user, that how they have to subtract, how they have to include the borrow and everything. So this is very easy and simplest way. This is also fastest way to calculate subtraction of two numbers. So I hope students that it is clear to you that how you have to subtract two numbers by using ones complement method. Now look at this example. So I have taken a one more example. So let's start from this example. Look at the question. The question is subtract 1010 from 1111. So what we have to do is, this is the complete description. So the number is 1111. So write the number as it is, 1111. Okay. The second number is 1010. So you just have to convert it into ones complement. So first of all, write it as 1010. Now perform the ones complement of this number. So let's move to this step. The original number is, larger number is 1111, and this is the ones complement number, that is 0101. Now add these two numbers. After adding these two numbers, we are getting the result as 0. 1 plus 1 is 0 with 1 carry, 1 plus 1 is 0 with 1 carry, triple 1 is 1 with 1 carry, 1 plus 1 is 0 with 1 carry. So this is the carry, that is 1. Now add this, remove the carry from this position and add this carry to the least significant bit. So after adding 1, you get the result as, you always have to start from the least significant bit. Okay, so 0 plus 1 is 1, 0, 1, 0. We have discarded that one. So the final answer is 0, 1, 0, 1. So students, that's all for today. Tomorrow we will start with next topic, that is subtraction using 2's complement. There is one more method to perform subtraction of two numbers by using 2's complement method. So that's all for today, where we have studied one's complement, what is 2's complement, and how we have to perform subtraction using one's complement. So that's all for today.